Hello everyone, welcome to my YouTube channel. In my last video, I have discussed about the rank nullity theorem, its statement as well as proof. So if you want to see that, you can watch my previous video. Today I am going to discuss a very important short trick related to the linear transformation. It's hard for us to check all the properties of linear transformation in case if we are in a competitive exam. So today I will tell you about a short trick because of which you can easily check out that the given transformation is linear or not. So let's start with our first example, that is, let t is a transformation from r square to r square such that t of xy is equals to x plus y comma x. Then can we say that this t is linear transformation? If we want to say that, we have to check vector addition, scalar multiplication, then we can say that. So it's a long process. So today I will tell you a short trick. That is, we have to, in order to check that the transformation is linear or not, we have to check the degree of each term given in the transformation. So the degree of each term is 1 here. So we can say this transformation is linear because the degree of each term is 1. So this t is linear transformation. And I will also check by all the properties. So let's check the properties also. So for that, we have to take two vectors from the vector space R square. So let x1 comma y1 comma x2 comma y2 be the two members of R square. Then we have to check t of x plus y. Then this becomes t of x1 comma y1 plus x2 comma y2. Now if we apply component wise addition, this becomes t of x1 plus x2 comma y1 plus y2. And if we apply the definition of the given transformation, this becomes x1 plus y1, and at the second position we have x only. So this becomes x1 plus x2 plus y1 plus y2 comma x1 plus x2. So this can be written as x1 plus y1 comma x1 plus x2 plus y2 comma x2. That is equals to t of x1 comma y1 plus t of x2 comma y2. So the linearity property is satisfied. Now we have to check the scalar multiplication. For that, we have to choose one scalar from the field R. So let alpha belongs to R. T of alpha x equals to, let x be x1 comma x2. x1 comma y1 belongs to R square. So t of alpha x becomes t of alpha into x1 comma y1. That can be written as t of alpha x1 comma alpha y1. Now we will apply the definition of the given transformation, that is x plus y. So this can be written as alpha x1 plus alpha y1 comma alpha x1. Now if we take alpha outside, this becomes alpha x1 plus y1 comma x1. So this can be written as alpha of t of x1 comma y1, and this can be written as alpha dot t of x. So we can see all the properties of linear transformation is satisfied, but this is very long process, and from here, by checking just degree, we can directly say that this transformation is linear transformation. So this short trick is really very important for us, and but there are some restrictions. We can't say by taking the degree as 1 that the given transformation is linear. Sometimes we have to see that there is any constant or not. So today I will tell you about that how we can determine that the transformation is linear or not in case if the degree is 1. So our next example is a transformation t of xy is equals to x plus 1 comma y, where t is from r square to r square. Here the transformation, each term has degree 1, but a constant term is also present there. So from here we can say that this transformation is not a linear transformation because a constant is involved in the transformation. So whenever you see a constant in the definition of transformation, you will directly say that the given transformation is not a linear transformation. And I will check it by all the properties of transformation and show you that this is not a linear transformation. So let t of xy is equals to x plus 1 comma y. Since we are taking the vectors from R2, they must be in the form of x1 comma y1. Let this x be equal to x1 comma y1 belongs to R square. And let y is equals to x2 comma y2 belongs to R square. Now if we apply the definition of transformation, this can be written as t of x1 comma y1 comma x2 comma y2. If we apply the definition of transformation, we have to add this because we are going to calculate t of x plus y. Now this can be written as by using the component wise addition, t of x1 plus x2 comma y1 plus y2. Now we will apply the definition of the given transformation. This becomes x1 plus x2 plus 1 comma y1 plus y2. In order to show that the vector addition holds, we have to show it equals to t of x plus t of y. But this will never be equals to x1 plus 1 comma y1 plus x2 plus 1 comma y2. This can't be equal to it ever. So this is not equal to t of x1 comma y1 plus t of x2 comma y2. That is, t of x plus y is not equal to t of x plus t of y. So from here we can directly say that t is not a linear transformation. Not a linear transformation. But with the help of trick, we can directly say that this is not a linear transformation because one constant term is involved. So you can see this short trick is how much important to check that the given transformation is linear or not. So let's take some more examples. So this is our third example. T is taken from R2 to R2 and defined as t of xy is equals to x square comma y square. Here we can say just by checking the degree that the transformation is not linear transformation because the degree of each term x and y is 2, that is not linear. So we can say directly that t is not a linear transformation. Not a linear transformation. Now we have a very important note point. After that I will take some of the questions and then I'll stop the class. So t is not a linear transformation. I hope the trick is clear to all of you, and let's have the most important note point of today's lecture. That is, so the note point is, if x square plus y square or xy, that is the term which has degree more than 1, or any constant term or any modulus function is involved in the transformation, then we can directly say that t is not a linear transformation. As we have seen in the above examples that there were x square plus y square and there was a constant term in the second example. So with the help of this note point, we can directly say that the transformation is not linear. So let's have some questions regarding the transformation. So our question number 1 is, let T be a transformation from R cube over R to M2 over R. M2 over R is the set of all vector space of all 2 cross 2 matrices with entries from the set of real numbers given by the following. So which of the following is a linear transformation? Option number 1 is T of xyz equals to x plus y, x plus z, y plus z and 0. 0 doesn't affect the linearity of a given transformation. So if there is 0 in the linear transformation, we can say that the transformation is linear because 0 has no value. Now T of xyz is equals to y plus 1, z plus 1, x plus 3, x plus y plus z. The transformation is linear because each term has degree 1, but constant term is also involved. That's why this option is not right. Now, if we see our option number C, as I have told you in the note point that modulus function should not be there if you want to say that the given transformation is a linear transformation. But here a modulus term is involved. So from here directly we can discard this option, that this option is not right because the transformation is given in the modulus form also. Now t of xyz is equals to x plus 3y z square 0. This is not linear and one constant term is also involved. That's why this will also not form a linear transformation. So the only option that is correct is the A option, because that each term is linear and no constant terms are involved. This 0 have no value. That's why this option is correct, and you can check it by yourself. Now I am going to take the next question. So our next question is, which of the following is a linear transformation from r cube to r square? So the first transformation is f of x y z is equals to 4 comma x plus y. This transformation is defined from r cube to r square. That's why this vector is in the column form of 1 cross 3, of 3 cross 1, and this is 2 cross 1 matrix. And since one constant term is involved in the transformation, that's why this option is not right. That is, it is not a linear transformation. Now just move to the next option. G of xyz is equals to xy x plus y. This term is not linear because the degree is more than 1. So this option is also not right. This is not a linear transformation. Now if we move to the third option, then this is h of xyz is equals to z minus x comma x plus y. So this is linear and all the properties of linear transformation is satisfied by this option. That's why C option is correct. So I hope that short trick related to the transformation, linear transformation, is clear to all of you. And if you are liking my content, please subscribe my channel. Thank you.